with creating and interpreting what we call histograms. Now, histograms look very similar to a bar graph, but they have a couple of key features that separate the two. So, bar graphs typically deal with categories and then it ranks those categories. So, like here, it looks like we're talking about something to do with money within each country. So, let's say USA has close to $200, UK has right under 400, and so it's dealing more with categories, and then there's gaps to separate each of those bars. However, a histogram, you're going to deal with number ranges. So you're going to separate whatever your number set is into ranges. So you might say 100 to 150 or 150 to 200. And then you're going to rank the frequency that those numbers occur within that range. So, and they also don't have gaps. So let's look at an example. Let's see. Let's look at the one from your opener, number 3, and it gave us the daily high temperatures of Jackson at the end of May in 2019. So it gave us a few of the temperature highs from that month, and it's asking us to create a histogram of it. Now, the first thing that we need to do is group these into ranges. So I went ahead and did that for you. We have the 87 to 88 range, the 89 to 90.9 range, and the 91 to 92 range. Now, typically these ranges need to be pretty even, and these are pretty close to being even for the data that we're given. Now, the next thing that we need to do is note the frequency of each. So let's go first and look at what's in the 87 to 88 range. So I'm going to look through my data, and anything that falls within this number range, it looks like 88 is the only one. So this one is going to go up to 1. And I'm going to make a really big rectangle for this one because I know I don't need gaps. Now the second one that we want to look at is the 89 to 90.9 range. So let's see, these fall in it. These are above it. 89.1, 89.1. So it looks like we have 4 that are going to fall in that range. So I'm going to continue my little rectangle. So this one's much taller to show that it has a higher frequency. Now the last one that we have here is 91 to 92 range. So we have 91, 91.9, 91, 91, 91. That's going to be 6 in total. We're going to come up and draw a line at 6 and bring that back down. So this is my histogram. There's a few things that we can interpret from the histogram. So let's see. What kind of population distribution does the data come from? Now this is coming from temperature ranges, and it looks like most of our population is falling in the 91-92 range. How spread out is the data? Well, it's not evenly spread out per se, but most of it again is in the 91 and 92 range. Is the data symmetrical or skewed? Now let me give you an example of what symmetrical would look like. So if I were to trace kind of like, think of this if this were kind of like a dot plot or like a line graph, this one kind of starts slow and then goes up. Okay, but if this were symmetrical, it would start slow, go up in the middle, and then go back down. So this one is actually skewed to the right, is skewed to our higher temperatures. If it were symmetrical, the higher range would fall kind of in the middle temperature. So this one is skewed. Any outliers? So remember that outliers is any number that's way off the data set. Now this one, I wouldn't say that we necessarily have any outliers. The 87 to 88 range only has 1, but that's not too far off from the 89 to 90.9 range. So this one doesn't have any outliers. Now if we had something that was like 17 was the frequency, then maybe that would be an outlier on the upper end. And then what is the mode? Now the mode we can get from our actual data set, and we can see that the number 91 occurs the most. Now, whenever we go to look at the actual histogram, we can't tell exactly what the mode is because remember, this is a range. So I know that the mode is probably between 91 and 92, but what if I had 3 91s and 3 92s? We don't know just from looking at the histogram. So the mode has to be determined from the data set itself. So this is just kind of a brief summary of a histogram. So use this information to analyze the histogram in the question below and then create your own.